Welcome, ladies and gentlemen, to this Mars Habitat Challenge 2022 here at Hagerbach and also online virtually outside. So thank you much for joining this hybrid event. My name is Stefan Steiner, co-managing director at Venture Lab, and it's my great pleasure to be back here for the second Mars Habitat Challenge. So if you are on social media, it's #Hagerbach, and you can also mention Venture Lab and Mars Habitat Challenge. So please share your impressions. Also, if you're joining from online, that's the opportunity to tune in, that you see what's happening here underground at this fantastic event location, Hagerbach. So just a few words. Venture Lab helps the best Swiss startups, so that's the company. And then I will shortly introduce also the two hosts, Mr. Kompatscher and Mr. Admiral. And you will see 5 startups today, but Venture Lab helps building startups since 15 years. And behind me, you see some of the scale-ups that are already well ahead. And I hope to see the 5 startups in the future as well on a similar slide with the support of this Mars Habitat Challenge. Before we jump into more detail of today, I will show you quickly the agenda. So we are already in the welcome note, and then you will see 5 startups pitching later on. And please pay attention, because we will ask you to vote for the best pitch, and there is a fantastic prize. We will talk about that later. So you can vote in here, but also online. So make sure you have your smartphone, your computer, tablet ready, connected to the internet, so that you then can vote later on for the best pitch for the startup afterwards. Then we will have Nanja Strecker from the European Space Agency on stage with a keynote to see what's beyond the whole Hagerbach, so in space out there. And finally, we will see who will be the winner of today, which startup will win a proof of concept here at the Hagerbach, and for the people on site, followed with an apéro afterwards. And now it's my great pleasure to welcome on stage Mr. Kompatscher and Mr. Admiral, the hosts, and we are looking forward to learn more about Hagerbach. First, Mr. Kompatscher, please tell us more.
Thank you, Stefan. A warm welcome also from my side. It's a pleasure to have you all here, that you found the way here to participate physically. I heard that some could not come because currently there are some activities, also pandemic related topics. So I'm sorry for that, and I'm very happy to have you online here to participate and to listen to these innovative new startups. Hagerbach is a innovation partner with our partners, and it's a pleasure to help also startups with the testing environment underground that we have here in our underground facility. It's about 5 kilometers of underground extended network where you can do innovation, where you can test one-to-one testing and find out the best innovative solutions. But why do we do this? Last year we celebrated our 50 years anniversary, and we said now we see that there are a lot of innovative young entrepreneurs coming also on stage, also together with the universities. And we said we would like to do more also for these interesting groups. And we had an initiative presented and launched last year called Mission Earth First, together with the ITA Committee of Underground Space. And it's a pleasure to have the co-chair here with me, Han Admiral, and he will tell more about the idea behind Mission Earth First and the Mars Habitat Challenge. Han.
Thank you, Michael. Quite a challenge to do that in 5 minutes, actually. So I hope somebody is timing, otherwise I'll keep going and we'll miss the apéro at the end. The ITA Committee on Underground Space was actually set up to explore the possibilities of using the subsurface beneath our cities. What we were seeing, or what we are seeing worldwide, is that we are gaining in terms of population. We are seeing that the cities are growing bigger and bigger. At the same time, we have issues of sustainability, we have issues of resilience. And we were thinking, can we use the subsurface more to meet these challenges that cities are facing? And indeed, I'm co-chair of the ITA Committee on Underground Space. Antonio Conaro is the other co-chair. And together we wrote a book called Underground Spaces Unveiled, Planning and Creating the Cities of the Future. And in the book we describe all the aspects of actually exploring, but also developing below the surface. One of the chapters of the book looks towards the future. And we thought, okay, so what is going to change towards the future? And an interesting innovation that's coming up is, for example, the Hyperloop, where we have high-speed traffic that goes well beyond the high-speed trains in terms of the speed that you can get in transporting people. And that will change. That will change the way that we travel. That will change where we work and where we can live. If you can travel from Rotterdam, where I live close by to in the Netherlands, to say Berlin in less than 30 minutes, that is going to change. That's going to have an enormous impact. But we also ventured out into outer space. We said, what if we're going to the moon? What if we would go to Mars? Is there any reason there to look below the surface rather than to stay on the surface? Now, we're all familiar with these very romantic visions of what it's going to look like when humanity reaches the red planet. But that is just a dream. That is just a romantic picture to kind of say, well, this is what it could be like. But it's not reality. There are big storms on Mars. But there's something out there. As soon as we leave our own atmosphere, there is radiation. And that radiation is a huge problem. So we could see that people were already thinking about, can we actually go below the surface? Can we actually use the lava tubes that we know are on the moon? Could we use those for habitation? To make a long story short, we started Mission Earth first together with 4 other partners, and we said, when it comes to this planet, we need to change our ways. We need to start doing things differently. And the challenge of going to another planet brings up the question of how are we going to create our habitats? Those habitats need to be self-sustaining. Those habitats need to have to produce their own food. They have to destroy their own waste. They have to do a lot of things which we take for normal in our cities. Indeed, if you look at a city is nothing more than one production engine, or consumption engine. We're consuming all the time. We consume energy, we consume water, we produce a lot of waste. But everything needs to be imported into the city. But if you're self-sustaining, if you're out there on Mars or if you're out there on the moon, you have to do it by yourself. You have to go back into becoming a self-sustaining habitat. And it is this idea which is core to Mission Earth First. And we're saying, if we look at these habitats that might need to be created on other planets, if we can use that idea and from there take suggestions on how we can start doing things differently on this planet, that would be a major achievement. That would be the goal, the ultimate goal to which we are looking. And in our opinion, a lot of that needs to be taking place below the surface. So we are looking here at Hagerbach, can we build underground data centers? Can we produce food below the surface? And maybe you'll see some of that later on when you do the tour here. So in a nutshell, Mission Earth First is trying to bring together 2 worlds, the worlds of outer space exploration and the world of how do we deal with the challenges here on this planet. If we can bring a connection between those 2 domains, that is great. And that is, I think, the core also of the Mars Habitat Challenge. We are looking for startups that come up with really original ideas, with new ideas, but also with ideas that can be used here on Earth for all kinds of new developments. So I'm very hopeful that we're going to have a great afternoon, Michael.
I'm looking forward to it. Thank you, Han. At this point, I would also like to thank our sponsors that made this possible. I think it was also very important for the startups that I can do this as a Hagerbach, but it's a different thing if you do the jury session and the selection with an external partner, Venture Lab, supporting the startups. We do this with Implenia, which is one of our shareholders as an international contractor, leading contractor. We do this with ACCO. CEO is also here as an international expert in dewatering systems and polymeric concrete. You see the different partners also here. There is Sika, also one of the sponsors, and was part in the jury. They are experts in construction chemicals. We have from our ecosystem, we have also Elkuch as a safety door, but also as an expert in mechanical components involved. We have Rova Tunneling Logistics. Underground has a lot to do with tunneling and tunneling challenges. You mentioned the Hyperloop topic. We need to reinvent certain topics the way we do. And within Mission Earth First, we have the Scout Association, the Swiss Center of Applied Underground Technology. There is the think tank from Liechtenstein, the Hus Institute. There's Itacus, there's VSH, and of course, there's the Amber Group, where we also belong to. And I think this is showing a bit the interest and the variety of partners we have in, and where we said we can use the Habitat Challenge also to have interesting startups, completely new innovative solutions on stage. With this, I give back to you.
Excellent, and I think there's a big thank you to the partners and sponsors, so give them a big applause to make it happen. Thank you very much. And as already heard, so we had a pre-selection, a jury who selected the top 5 startups that will pitch today here at Hagerbach. And you will see 5 startups. Each of them will have 5 minutes to pitch on stage. And as I mentioned before, at the end, after all the 5 pitches, you on site here and also online, you have the opportunity to vote for the best pitch, and there will be a final prize. So 5 minutes for each startup, and we will start with Saurabh. Please join me on stage and tell us more how you will help us with the energy problem in the future. The microphone is there, and welcome on stage.
Thanks, Stefan, and thanks all the organizers. I would not waste too much time, but directly jump into the pitch. So let me start with a very brief question, which is simple to answer, in fact, but which is very important. So wouldn't it be great if we could reduce our current dependency on conventional fossil fuels, which are anyway exhausting and are the major cause of damages not only to our environment, but these days they are at the center of geopolitical tension also. And wouldn't it be equally amazing if we could produce a fuel simply by using sunlight and water? The simple answer is yes, this would be great, and this is exactly what we do at So High Tech. So basically at So High Tech, we provide renewable systems for on-site production of fuel and power. And the fuel which I am talking about here is in fact hydrogen. So in fact, this is widely known that most of the hydrogen today is produced from fossil fuels itself, which kind of kills the purpose to have a clean fuel out of non-clean fuels. So what is our solution? Our solution is very simple. In fact, we want to mimic what actual trees do. So like trees, which use sunlight and water to give you nutrients and energy, and also shade, we have designed and developed our tree, which is called ARB. It's an artificial tree, which actually looks a bit like a real tree and which functions very much like a real tree. So basically what we do, we use sun and water to give you pure and clean hydrogen, which is the fuel. Also, we provide you pure oxygen, which is a life-saving commodity, particularly in this scenario where we are talking about habitation extraterrestrial. It produces electricity, it produces heat. So what we have is a very efficient and cost-effective fuel and power cogeneration system. So that's what we have developed. That's the basic building block, and basically what we provide is basically gardens and forest of multitude of these trees, which basically serves as your fuel and power production plants or farms. This is a real footage of the pilot which is up and running in Lausanne, by the way, at EPFL. Very briefly to summarize what's the key innovation here. What we have done, we use concentrated sunlight to break water at very high efficiency. In fact, what we have achieved is more than double than any other competing solution you would find out there. In terms of various highlights, not going into details about various awards which we have won, what I wanted to highlight, in fact, we do hold a world record for demonstrating the best performing solar hydrogen production system out there. And currently, in fact, we are deploying this already for industrial use case. All this definitely could be possible only with a highly motivated and competent team. We in fact come from EPFL. We are a spin-off from EPFL. Our technology is based on 10 plus years of extensive R&D. And currently, we in fact have 100 plus years of combined scientific and industrial experience within the team, which is basically taking the solution forward. Now, what's the relevance here? So as you may already know, on Mars, basically the environment is quite hostile. There are long darkness hours, and then it becomes difficult not only for the equipment to survive, but also for the astronauts, or if we go there, for us to survive. So what we need is a system which is versatile and flexible, who could produce not only energy, but also fuel, also oxygen, also water, and which can do this in a cyclic way. So basically, you can produce all these components, but you should also be able to use these components and get back the energy. So that's what we do. Our system basically can be used as a local fuel, energy, oxygen, and water production and storage solution for Mars or any other extraterrestrial solutions. In fact, you can operate it during the day, you can produce all the outputs, and during the night or during the non-sunny period, you can use and basically operate the entire system in closed loop. Overall, with this concept, we already have 2 R&D projects running basically with European Space Agency, and we are also part of prestigious ESA big Switzerland incubation center. With this, we are exploring basically deployment of our solution for space even further. To end the presentation, what we are basically proposing here, so this underground facility, Hagerbach Test Facility, in fact, very much mimics what we could do on Mars. You can create an underground habitat there, but how are we going to power it in a sustainable way? So that's what we are proposing. In fact, we propose a garden minimal of 5 trees, which is in a Swiss cross fashion, which basically can deploy hydrogen, which can be used as a fuel or even as a long-term energy storage solution. We can produce oxygen, which is a life-saving commodity, and eventually heat, which can be used for a variety of purpose, either heating or even for cooling. So that's it. With this, I end my presentation, and thank you all for attention. And do vote us for the award. Thanks.
Congratulations. Please stay with me. So we are looking if there is a question from the audience here. I do the ice breaking until we give them some time. So you mentioned that you have a pilot at the EPFL right now. So what is your timeline? When will we see that in fully production?
Yes, so our pilot at EPFL is already working. We have already demonstrated the full functionality, various performance figure. And at the very moment, we are already working on 2 industrial demonstration projects here in Switzerland. We are starting with steel processing sector. Basically, we are decarbonizing making and manufacturing of steel and steel components to start with. So we have 2 pilots, one in Aigle, one in Neuchâtel, which are up and under implementation phase. And beyond this, we already have multitude of other sectors. We are heavily targeting mobility, heavy mobility, be it trucks, buses. Cars are not yet there, but heavy mobility. We are planning other industrial sector, chemical fertilizer manufacturing, even cement manufacturing eventually, which can be heavily decarbonized with hydrogen. And we have basically these projects in pipeline for next year.
Excellent. Thank you, Shorab. 2 questions. Let's start with Mr. Kompatscher. Microphone is coming.
How do you make the hydrogen available? Liquid or in what type of way?
So when we produce, it's in gaseous form. But after that, depending on what you want to do with it, we can further liquefy it. So depending on the storage need, either we can compress it. Currently, we compress it in gaseous form, but you can also liquefy it depending on the use case.
Thank you. Next question, please.
Hi, Saurabh. So you explained how you could use your system for mass. There was one benefit that you didn't mention. Can you guess what it is? What is a key challenge for an exploration for Mars? Maybe anybody can chip in? No? It's also always important if you go for outer space. Anybody has an idea? The fuel for coming back.
Yes.
Because he's exploring his usage of green hydrogen for going to space. So that's the collaboration with us, with the ESA big program. But a key challenge for going to Mars is the fuel to come back. And I think you could contribute to that as well.
No, definitely. As I said, so the system in fact is quite versatile. And in fact, you did mention weight. This is something where we also excel in. Mass specific energy density is very important for anything you send up there. And this is one of the key things. It's not only about efficiency. With the particular mass, the output which you produce is in fact very high with our system. And definitely you produce hydrogen, which is a fuel. You can use hydrogen as a direct fuel. You can use hydrogen as an energy storage medium. Oxygen as a life-saving commodity. We can operate in reverse loop. We can produce in fact water from hydrogen and oxygen back and give you electricity and heat, which is a super interesting phenomena. So yes, the system is very versatile and flexible. Thanks, Nanya, for pointing this out.
Excellent. Thank you very much for your presentation.
Thanks.
We will see Saurabh later in the voting. So our next startup will also be from the western part of Switzerland, but we are talking about clean water and clean air. So two topics that are very important on Earth, but also in the future on Mars. Andre, please join me on stage and tell us more about your startup, Swoxit.
Thank you, Stefan. Good afternoon, everyone.
You need to click one more. Yes.
Good afternoon, everyone. My name is Andre. I'm environmental scientist from one of the leading Swiss Polytechnical University and the CEO of Swoxit. And in Swoxit, we are cleaning water and air with light. So according to NASA, for a deep space mission, 98% of the water consumed should be recycled. And 75% of the oxygen the astronauts exhale should be also recycled. So to do that, basically we need technologies where we are reusing recycling. And we know that for a sustainable future on Earth, we have to develop technologies for a circular economy where we are reusing materials as much as possible. But in the context of Mars, for a future Mars habitat, this is utmost important, even more important, to reuse, recycle, and repurpose materials. So at Swoxit, we have developed the new generations of reusable, long-lasting air and water filters. And this patented technology is basically an aerogel membrane which has nano-sized pores. And with these tiny, tiny pores, we are filtering out bacteria and viruses just as the best commercial filters do. However, what our filter does is that it's able to kill and decompose viruses and bacteria if it's illuminated by light. So on this side, you see a contaminated filter, and on this side, the part of the filter if it's exposed to sunlight. So where is the magic? The magic is that under sunlight, the filter is producing hydrogen peroxide. And hydrogen peroxide is a well-known disinfecting agent. It's also used for hair bleaching, can turn dark hair blonde. And by having this material, which is a very good disinfecting agent, we are able now to kill the bacteria and viruses, so the filter will last long and it can be a self-cleaning filter. On Earth here, we are using and implementing these filters into solar water purifier prototypes, which does not use any electricity, only gravitation and sunlight to sterilize water. We also implemented during the COVID pandemic into FFP2 quality reusable face mask, what you can use 1,000 times and easily sterilize in the UV box. And what we would like to do is to implement the filters into air conditioning, because we think in indoor air cleaning there's also a lot of potential. So in the Mars, if we imagine a habitat like this, we think that our filter could be used in the life supporting equipment to clean air and water, drinking water, showering. But it can be also used, for example, for food production. If you have a microalgae production system, we can reuse that water and sterilize again to grow microalgae again. As well as, you remember the case with the face mask, it can be used in scaphanders for astronauts to ensure clean air for an outdoor mission. So the good thing with our technology that the raw material, the titanium, is present on Mars. Almost 1% of the red soil of Mars contains titanium. So the filter could be produced locally eventually. The second good thing, that the ceramic filter is recyclable itself. So if you imagine products, water cleaning, air cleaning, masks, once they can be used many, many times, but one day nothing lasts forever, we'll throw it away. Now, this product can be again put into a reactor and use and make a new filter again. So it's recyclable like plastics. With Hagerbach, we would like to test our existing prototypes, so the solar water purifiers, to put into the test in the tunnel, as well as to build the indoor air purifiers. And finally, for cooling water and air, and for future intergalactic Mars holiday, please vote for us and help our technologies to bring to the next level with Hagerbach. Thank you for your attention.
Thank you very much, Andre, for your presentation. So we have time for questions from the audience. There's one from Carl.
Thanks a lot, Andre, for the presentation. I was wondering, do you have any current or past pilots or tests you have done, let's say on the buildings level or on water filtration or in the water industry? Let's say on more, well, industrial scales, maybe too fast, but at least on test scale.
Yes, thank you for the question. So pilot tests, what we are looking for are longer term ones. Shorter ones, which lasted for, let's say, 1-2 weeks of continuous operation of the water filters, for example, which are just out there. Currently they have a size of a laptop. That's the size of the filter what we are producing. Those type of filters what we are testing, and longer term pilots, we are in the stage that we are looking for longer term pilots to ensure that the filters are really operational for months and years, and really see where it can go as long as the reliability means. So no, the answer for the longer ones, that's what we're looking for. The maximum was 2 weeks continuous operation so far in South Africa in collaboration with the South African Water Institute. And what was interesting there, that the water was really, really contaminated. So it was wastewater degree of germs inside.
And maybe a short follow-up question, if possible. How long does the filter need to be exposed to UV to actually clean out the bacteria and the viruses?
Exactly. So the UV part is producing the hydrogen peroxide, but the visible part and the infrared part of the visible spectrum is heating up the filter, and that is basically doing the pasteurization effect. So we use also the heat part. It's solar thermal water purifier. We use the heat as well, and the filtration. So it filters, it produces hydrogen peroxide and heats up water. This is the three technology what we do when we think about sterilizing water. And this does free, basically. Can go with sunlight or with UV lamp as well if we have an electricity, depending on the conditions.
Okay, thank you.
Excellent. Thank you very much, Andre, for your presentation.
Thank you very much.
This is your applause. So we have now energy, water, and air. So next, how do we move on Mars? And it's my pleasure to welcome on stage a team from OpenATS. So they're producing 3D printed vehicles, and I'm looking forward to learn more from Lucas and his team.
Hello, my name is Lucas Pitcher, Lara Maya, Patrick Kumpold. We are the founders of OpenATS. OpenATS is a startup company from Zurich, and we are providing efficient, autonomous transport solutions by offering a scalable 3D printed ground vehicle. Yes, you heard right, a 3D printed ground vehicle. Here you can see our current model. And now Lara will tell you more.
As we all know, current transportation is fossil fuel. Heavy delivery trucks are being used even if they are not sustainable and expensive in labor and fuel. Our vehicles instead are much more sustainable and also more affordable because they are electric, 80% 3D printed, and have less emissions. Take a moment to think about it. Why are we delivering 2-kilogram meals with 2-ton trucks? Coming now to the different use cases and development stages of our vehicle. Currently, we are focusing on 3. The first stage will be the development of our vehicle. Then, if we get enough investment and support, we will focus more and more on delivery and transportation. The first stage will be the use of passenger and bicycle roadmaps for delivering packages and food. This is a 3.4 billion market. Now to the cost of our vehicle. Our vehicle costs in production about $600, which then will be split into $500 for the electronic components and into additional $100 for the 3D printed parts. We will sell the vehicle for $1,600, so if we produce and sell 3 vehicles a day, we will receive a revenue of $81,000 per month.
Thank you, Lara. So right now, let's move on with the technical part. Our vehicle, as we heard, is electrically driven. It can be accessed over a local radio network as well as the internet. For right now, we have written programs to control the motors, the steering, and the video streaming. The video stream is not only important for the navigation of the vehicle, it's also important for gathering data from dangerous places or unexplored areas. The current prototype we've produced, and you also can take a look afterwards, can carry cargo up to 2.0 kilograms. With our scalable platform, we actually look to increase the payload. The structure and the tires are fully 3D printed. That means that 80% of the total vehicle are easy to build. 3D printing allows us a very versatile build of complex structure and lightweight components, and it allows us to assemble it easily. This is very important because every gram of payload brought to the orbit is precious. Let's talk about the Mars. On Mars, additional polymers to print the vehicle could be synthesized due to the so-called Sabatier process. It's also possible to construct a vehicle from metals abundant on the Mars surface. Let's go to the Hagerbach Test Gallery. We really would like to test our vehicle in the tunnels, as well as the semi-autonomous driving, and the harsh environment of dust, humidity, and an uneven ground would be perfect to adapt our 3D printing process. Thank you.
Yes, our car is electric. That means it is perfectly compatible with solar and nuclear energy produced by electricity. It is also compatible, or it does not contaminate the air inside the Mars habitat by not outputting toxic gases or using precious oxygen. So here you can see some examples of our vehicle. On the bottom, you see ways of transportation. And on the top, you see our vehicle transporting some devices, like a robot arm or a high-resolution camera. And how you can see on all examples, the base stays the same. Therefore, we call it a mobility platform. We are pursuing the process by SpaceX and others. And now there's an opportunity to help, to make fundamental research and pioneer work. The OpenATS team wants to be part of it. Yes, outside there is a prototype. I invite you to have a look. And now I'm here for any questions. Thank you for your attention.
Thank you very much for the presentation. Keep the microphone for the questions. I will do the ice breaking until to get some time. So where do you see the future of 3D printing?
Yes, it's an advanced technology. And now it's only possible really with plastics, and some expensive machinery can also print metals. But yeah, 3D printing allows us versatile build and complex structure, which is yeah, not buildable with traditional manufacturing. And yeah, you can print every structure you can imagine with a 3D printer, with no complex toolery.
Great, we're looking forward to that. There is one question.
What are your plans to what payload you want to increase the vehicles? Now you say it's 2 kilograms, but ultimately 2 tons.
Yeah. Yeah, so of course we can use transmission to reduce speed but increase torque. We can also scale up the vehicle. So for now it's a relatively small vehicle, but now we are working on a bigger vehicle which then can carry more. But we are focusing more on rapid transportation, and yeah.
Great, thank you much for your presentation.
Thank you.
Is your applause? So our next startup, we will need concrete to build the habitat on Mars, and our next startup uses AI, artificial intelligence, to mix concrete. So I'm looking forward to the presentation of Franz to tell us what mixed arresting is doing and how they decrease costs in finding new mixtures with concrete.
Hello from my side. Thanks for having me. I'm Franz Haller, one of the co-founders and CEO of Mixed Resting. Thank you, Mr. Steiner, for the kind introduction. And I just share my screen to present you our solution, Mixed Resting, and how we can help you develop new and more crazy material in the future. So, Star Trek. Why Star Trek? Because one, I'm a huge fan, and two, what fascinates me most about Star Trek is that for every problem, there's a technical solution. And that's exactly what we see with Mixed Resting. Our digital mixing master helps to iterate 10 times faster than before, to help society for better, to gain knowledge in the material science sector, and to really, really be quicker and faster in development in new and more efficient building materials. So our vision, our software helps our customers, helps our users to develop new and more materials within just 2 to 3 iterations. At the same time, not having to change anything in the production method, with consistent quality through virtual simulation of promising materials. And this is our digital mixing master. And I will now switch to the screen where I'll show you how the system already works. So now you should see the screen. This is the surface. And what you need is you need data. That's right. That's clear. In terms of concrete, it is what you put in: sand, water, gravel, cement, super plasticizer, retarder, whatnot. So in the system, you can add any material you want, be it recycling material, new material, as long as you have some measurements about the materials and measurements of existing mixes you already did in the lab: compressive strength, tensile strength, table flow, etc. Everything you can measure, everything you have data you can put in the system will learn about the data, how your model behaves, and will try to iterate its own model. And what you do with it, well, that's the big question. The answer is the system helps you through virtual simulation of thousands of mixes, give you new and more efficient mix designs. And what does efficiency mean? Well, it depends on the use case, and the use case is given by the customer. Normally, the customer wants to reduce cement because concrete is a lot of cement and it's expensive in CO2, so they reduce cement. In your case, could be I want to reduce water because I have cementitious materials in abundance. So you can define the use case, you can define the constraints, and you can define the boundaries. And what the system then does, it gives you, as I said before, new mix designs based on your data and based on your constraints. So I will now flip back to the presentation. How does it work? We combine mathematical, physical, chemical models, how concrete, how cementitious materials work, combine that with mathematical algorithms for robust optimization, and with a machine learning model. The huge USP here is that you don't need hundreds or 500s of data points to start the optimization with. You only need 15 data points. This is for huge value, for example, if you use new materials you don't have so much experience with, or recycled aggregates. As long as you have some data about the materials, as long as you have some measurements, you can use it and our system can learn from it. We think with our software, you can develop new materials 10 times faster than before. You can reduce the amount of iterations about 90%, and you have quicker results you can test in real world or in the lab. How do we know that it works? Well, we started with crazy wood fiber concrete, where the literature was saying 5 years ago, this is not possible to create the wood fiber concrete with 25% recycled aggregates, still pourable, not inflammable, and compressive length 35. Well, the software didn't know that it is not possible from the literature, and after 3 iterations, we had this cone with exactly the desired results I just said. And the team behind Professor Hermann Schickel developed all the mathematical algorithms for it. Waltraud and Erwin are the brainchild from the material science. They inserted all the knowledge from material science, and our magic in the tool did the rest. And I'm from the technical, from the financial side. I keep all the eye on the financials and on the project. Yeah, and we're really excited. We are really confident, and we really think that we can help you be faster in development of new and more crazy materials. And we'll be really happy and really proud to make together and see where the frontiers of material science really are. Yeah, that's from my side. You have my contact here. Just reach me. And I'm really happy to see in person. I'm really sad that I can't be in person right now, but I really enjoy seeing you online, and all the best. Thank you.
So you see, we not only have Swiss startups, also one from Austria who made it into the final, and as we heard from Sorab, so light is an issue on Mars, and that's last but not least with our 5th startup. We will talk about light and how light will help us to survive. I'm looking forward to the presentation of Christina from Lease Technologies. And Christina, please tell us more about your solution, how you will help us with light.
Thank you very much, Mr. Steiner, for that introduction. I'm very proud and honored to be here today to present to you. I'm just going to share my screen to show you my presentation. So it should be on your screen now. So I'm here today to present to you Lys Technologies. Our core mission is to help people live healthier with light, and everything we do is based on science, powered by data, and enabled by technology. And my name is Christina, and I'm one of the co-founders here at Lys. One part of the problem is that we're tackling is that light is the main influencing factor on our human sleep and wake cycle. Poor lighting can cause life-threatening health problems, and scientific research shows that bad lighting on the sort of short term can result in things like low energy levels, poor sleep, and poor cognitive performance. And then on the long term, we see things like that it can lead to serious lifestyle illnesses such as chronic diseases like cancer and cardiovascular diseases. And we're talking about light that is perceived through the eyes, the retinal ganglion cells in the eyes, and is then controlling our different hormone production in the brain. So that's one part of the problem. The other part of the problem is that existing lighting solutions are not really optimized for human health and well-being. Typically, the sort of the interface is quite outdated, and it's operated manually, which is not optimal when you want to personalize lighting for people's conditions. And here I'm really talking about things like chronotype and sleep-wake cycles, but I'll get back to that. And if you just look at that sort of timeline of light's evolution, we started by evolving under natural daylight for thousands of years. And we had the bonfire at night, which was very sort of warm, and that's what helps us produce melatonin in the brain to prepare for sleep. And then in the 1800s, we invented the incandescent filament lighting, which was still quite warm, similar to the bonfire. So it didn't really disrupt our sleep-wake cycle until the sort of the progression of energy-efficient light, the LEDs, which is very blue, bright light, and that's where the problem really started to arise, because we would get similar light to daylight in the evening, and now we have things like connected lighting, but the problem is that it's not really personalized or optimized for health and well-being. With Lys Connect, which is our newest product, we can transform uninhabitable environments into habitable environments using light. So when you talk about astronauts, the problem is that sometimes they're scheduled for non-24-hour operations and exposed to 92 minutes orbital dark cycles. That means that their biological clock will be misaligned and they will be imposed for sleep-wake schedules. That increase their potential for sleep loss, and then in turn that can increase things like risk of accidents at work, etc. So if you look at light in space or humans in space, they will sometimes have 16 sunrises in one day. So it goes without saying that actually that is very disrupted to our normal circadian rhythm, our normal day and night cycle. There's plenty of studies out there showing that light has a huge impact on performance and of course sleep and wake schedules for people in space, and then many done by NASA. This one in particular is focusing on the moon and Mars, which is very relevant to this challenge, and done by Stephen Lockley. And the really interesting thing here is that they could see by introducing dynamic lighting schedules, they could facilitate circadian adaptation and shift teams' timing of sleep and wake cycles, which is very, very useful when you talk about human health and well-being in space. So Lys Connect that I just introduced is a light source agnostic solution that is truly personalized and automated. It's similar to any smart system that you might know. There's an app and it connects to light bulbs. It can be many different light bulbs, but now I'm just showing the E27. And basically what it does is that we take starting point in a person's chronotype. There's 7 different chronotypes from academia. And people know about night owls and morning people, but actually here we can be a lot more precise. We look at the biological chronotype versus the one that they're trying to live their life after. And from that, we can understand the amount of social jet lag. We can go into depth around when is the optimal time for bed, when is the optimal time for wake up, when is the optimal time for physical performance, optimal time for cognitive heavy performance. But obviously also how can we expose them to the right light in order to keep the best sort of circadian rhythm, the best day and night cycle for their needs and their chronotype. Just to talk a bit about the business case, the whole point of this system is really to get the right light at the right time. And we also sell it into normal indoor environments. So like most people nowadays, they spend more than 90% of their time indoors. So they will not have necessarily the exposure to natural daylight. So with this system, it's not only going to space or underground or other uninhabitable environments, it's also just like indoor environments where people don't have access to natural light. And we can do things like help people sleep better, get more energized, be more productive, and improve moods. Just a small note on our team. We're 6 people in the main team. I'm Christina and my co-founder Hugo. I have a background in innovation design engineering. Hugo has a background in healthcare strategy consulting, but also biomedical engineering. We have Nikolai, which is our CMO. Then we have Forrest Webler, which is our CTO, and he has a background, just finished his PhD at EPFL in circadian rhythm science and light. Alex, our technical lead, and Swan, our data and science and machine learning expert. I just wanted to say that initially we developed a light sensing device that connects to a phone, and we're selling that mostly into research. So we have research clients across the world, companies like Stockholm University, UCL, Harvard University, EPFL, the DTU, Hotel Dieu in Paris, and University of Bristol. So we have a close relationship to research and academic institutions across the world. So in terms of the feasibility to test in the gallery, this is something that that we can do fairly soon. We already have a prototype up and running, and Forrest is very connected in Switzerland with the EPFL, so he would be able to sort of work with students there as well to get something quite amazing up and running. And we think it would be a really interesting test case for our product. And really together, we think we can transform uninhabitable environments into habitable environments with light. So that's it from us. So Luz Technology, everything we do is based on science, powered by people, and enabled by technology. And I just wanted to say finally that I'm really sorry that we can't be there today in person. And I just hope we get to meet each other at another time. But I wish you a brilliant event. And if any of you wants to get in contact, Shao would have my contact details, and I'll be really happy to have a short chat or whatever you think is necessary. So enjoy the event, and thank you so much for getting the opportunity to present to you today. Thank you very much. Bye.
Thank you very much, Christina. So thank you much for listening to these 5 presentations. And as I mentioned before, now you need to take out your smartphone or your tablet computer, because we will go into the public voting, and go to menti.com, and then you can add the code 68126866, and then please choose a startup that you think was the best pitching, and there is a fantastic prize. So they will win a proof of concept here at Hagerbach. So menti.com, and the code, you will see that. So you can vote until we close the voting after our keynote. So menti.com and 68126866 is the code for voting. And I mentioned we will have a keynote speaker. It's my great pleasure to welcome Nanja Strecker on stage. So the European Space Agency Business Incubation Hub, or Business Center, sorry for that, in Switzerland. And we are very much looking forward to learn more from you what the European Space Agency and Mars Habitat Challenge have in common together. Nanja, stage is yours. Thank you very much for joining us.
Thanks a lot, Stefan, for the kind introduction, and thanks a lot, Mr. Kompatscher, for having me here. I just turn around correctly. So just to be clear, I'm not an employee of the European Space Agency, but I'm an employee of ETH in Zurich. We are hosting the ESA Big for Switzerland for the entire country. And I'm very happy to be here to give an introduction to our program and what we do for startups. And it's my real pleasure that we have one of our incubated startups here today with Sorab, and we'll ask him a question later. And very importantly, ESA is not the EU. I hope you know the difference. Switzerland is part of ESA, but not of the EU. It's an intergovernmental organization, but it has no direct connection to the EU. So we are part actually of an international network of business incubators around Europe in ESA countries. And Switzerland was one of the later ones to start at the end of 2016, early 2017. The first one to start was in the Netherlands, next to ESA's tech center, ESTEC in Noordwijk, already in 2004 or so. But nevertheless, we started late, but yeah, we are well known, have a very good reputation across Europe, because actually the Swiss ESA delegation negotiated something different with ESA, and we're the only ones in Europe so far to have a program like the one in Switzerland. So we're a bit of the benchmark. And we meet our colleagues in the other countries twice per year, and both the startups and we as the center can benefit from the network. Quickly about the program. In terms of the program, we are purely for startups. So it's not for SMEs, it's startups based in Switzerland, less than 5 years old. You need to be headquartered in Switzerland, so it's not relevant to all the startups who pitched today. So an R&D center only in Switzerland is not sufficient. It needs to be the headquarters. For the reason that you have seen before, there are such centers in the other countries as well. And there needs to be a space connection. We'll go into that into more detail, because obviously that's the key differentiator of the program. In terms of benefits of the program, you get 200,000 euros non-dilutive funding. So we don't take any equity, which is quite high in Switzerland as well. There's only one program which gives more, which is the base launch for pharma and biotech in Basel, because they need even more money than doing things for space. And in addition to that, you get technical and business support as a startup. There's community events. You regularly meet the peers in the program. It's all kind of benefits associated. And there is 2 deadlines per year. If you know any startup, I definitely consider a few of the ones presented today could apply to our program. The next deadline is end of October this year, and the selection is in November. So also if you know friends, etc., who could have a space connection, could be relevant, please spread the word. And now we have a little video to explain the space connection. I hope afterwards you know more about it.
Space is open for business. Why not explore your space connection? For entrepreneurs and startups, the possibilities are endless. You could apply technologies from space here on Earth. Today, the solar cells used in satellites in space are being used to build highly efficient solar panels for use on Earth. You could adapt technologies from Earth for use in space. One startup is reinventing their cybersecurity solution from the financial sector to protect communication via satellites. Or you could contribute to a whole world of space data applications. One successful solution uses satellite imagery to help farmers deliver the perfect amount of fertilizer with pinpoint accuracy. Even if you haven't considered space as yet, you can benefit. Whether it's from Earth to space or from space to Earth, we're here to get your ideas off the ground. So, what's your space connection?
As you can see, we also use this video in information sessions for potential applicants for the program, but I thought to introduce the space connection, it's also helpful here. There was actually one category missing. So there's from space to Earth, from Earth to space. There's space data application, and the 4th category missing because it's so evident, it's purely for space. So we have 2 startups, I will mention them later, who are purely for space as well. In terms of the business segments related to space, it's very diverse what we have in the program. Starting on the top right, exploration and cleaning. You might be aware that it's a huge issue nowadays, all the waste that is flying around the Earth. And one startup that we supported and is by now quite famous in Switzerland is called Clear Space. Maybe you have heard of it in the media. They will collect space around, flying around the Earth. Actually only started once they were accepted to the ESA Business Incubation Center in Switzerland. So we're quite proud of that. Sensing, obviously, on Earth and in space, telecommunication, security, you heard that in the video as well. We also have startups in there, all kinds of components for satellites, for the ISS, etc. Materials and processes, always a topic in space, and space data applications. So it's really quite diverse. I will show the portfolio in a second. So that's the portfolio nowadays. At the top in the white circle, you see all the startups currently in the program. They're in the program for 2 years, and we have roughly around 20 at one certain time. Yeah. And in the bottom, at the bottom in the gray box, you see all the alumni that went through the program already. And for the ones who were here last year as well, you see also Anybotics. They were also part of the ESA Big program at some point, and they're currently finalists of a new ESA challenge with their animal robot. And at the top, you see in the Lausanne kind of circle, obviously the majority is from ETH and EPFL, naturally. You see So High Tech with SORAP. Also supported because ESA is looking into green hydrogen solutions, and that's why SORAP was accepted to the program as well. But we are always happy to support startups also from other corners of the country, and we have again a startup from Lugano, we had one from Davos, we have one from Geneva nowadays, so we are always happy to have other ones than Lausanne and Zurich. About the process, I will do that very quickly. There is a selection procedure, and then if you get into the program, there is a first kind of period to prove yourself, and there's an assessment after around 4 to 5 months, where it's checked like if the startup is performing according to the expectation, if there is a fit with the program. And I have to say the vast majority went to the second phase as well, but some left because there was no adherence with the program. And overall, it's 24 months long, 2 years, and you have the support along. In terms of results, we've supported over 50 startups by now. The money that we paid out is over 8 million already. So these are the 200,000 that I mentioned earlier, multiplied with the startups. But the money is not paid on upfront as a grant, but it's paid over the 2 years, linked to certain milestones that we agree with the startups. And what is very dear to my heart is that over 15 startups or even more already have revenues more than 1 million, because we want to help to build businesses and not only to fundraise money, which is also nice and important, but eventually it's about building businesses. So coming to the partner wheel, but I want to go one step back before doing that. In terms of benefits for the startups, I want to ask actually SORAP. So SORAP, you know, you've been in the program for over a year now, a year and a half. Can you quickly state some benefits that you experienced for the program quickly? I thought I'd take the advantage that he's here already.
Cool, thanks. Firstly, I would go a step back and first describe basically why we are in the program. It's not only about green hydrogen, because yes, hydrogen is a fuel for rockets, definitely. But I think we have a dual connection with space, yes. So we satisfy multiple criteria. We in fact use certain space technology in our solution. And eventually we are deploying our solution also for space use case. So this is the dual connection. Now in terms of key benefits, I think I can go on and on. To simply put it, like if you...
2 or 3, SORAP, please.
Exactly. So apart from the monetary support, which is definitely nice at the right time, I think we heavily benefited from what is shown over here. So because when we joined the program, we were at the stage when we were going from, let's say, proof of concept towards industrialization. So this was the time when we needed to be connected to a lot of partners, basically to take our solution forward in terms of industrialization, and also to find new use cases, which is basically for using hydrogen as a fuel for launch station for space. And this has been instrumental. I could say currently, I think 30 to 40% of our partner network, in fact, comes directly or indirectly via ISABIC program, which is a great thing.
Thanks a
So
lot,
thanks for
Sorab.
this.
But Sorab is also playing it smartly. Not every startup is benefiting as much as he does, but he plays it smartly. So the more you ask for in a specific manner, the more you get. Thanks a lot.
We are squeezing every bit out of the program. Thanks.
Thanks a lot. Looking at the partners up here, it's not about logo dropping. It's really that we have contracts with all these partners and they give a bit of a financial contribution. But what is now much more interesting, beside the financial contribution, is the in-kind support that the startups like So High Tech and Sorab can get. And that is very, very much appreciated by the startups. And what I didn't mention in the beginning, yes, we are employees of ETH Zurich, but the whole team comes from industry. And we function a bit differently than some other colleagues there. And we also have networks that span far beyond the network that you see here, and we use them as well. So you're probably also in contact with partners that are not mentioned here, that come from some network of our technical expert, etc. And we also have an investor network. They are not shown because investors don't want to sign contracts and pay anything, but they are shown on the website. And we also have service providers, software providers, etc. In addition to that. Coming slowly to the end, another benefit I think that Sorab did not benefit too much yet, but he's going there this year, is that we go as a team either to space exhibitions, conferences, or specific startup conferences or exhibitions. You see some pictures on the one side, it's about Slush, a big tech startup conference in Finland every year. We go there also with the ISABIC in Finland. And at the right, you see the International Astronautical Congress, for example, that our colleague was there last year in Dubai. And actually, this is where Sorab goes this year. The IAC is taking place in Paris, and he will be one of the 3 startups going with us to this event. So that's another benefit. We also pay a bit, contribute a bit financially in terms of the tickets, travel, accommodation, etc. Last but not least, the program is about 5 years old. And in the beginning, it also had the motivation in order to stir up a bit the ecosystem of space in Switzerland and give it a new dynamic. And I allowed myself some reflections, and I will add some additional notes in terms of how we did give it a new dynamic in Switzerland. I will start with a few points that are not noted here. I mentioned ClearSpace. ClearSpace got a contract with ESA for over 80 million, including also partners. And ClearSpace is the first startup that ever got a contract with ESA, and it's the first time Switzerland has a prime. So it's a prime contractor of a mission. That never happened before. So that is very unique. And the Airbus, the RUAG, now called Beyond Gravity, and the likes, they are partners and suppliers of ClearSpace. That's a new dynamic, you know. ClearSpace tells RUAG or Beyond Gravity what to do and not the other way around. Huh? Another thing that happened as well, you might know Swiss 212. It's another important startup in the ecosystem. They do 3D printed antennas for space as well. And they have a very senior former executive of RUAG Space as their chief commercial officer. Also not seen before. So there's all kinds of new things that happened, like with creating an ISABIC in Switzerland and the contribution it made to the ecosystem. Now going back to startups, space stays a bit of a special ecosystem with a special language, a special way of functioning, which is also quite slow. And we need to build the bridge. So we have space experts in the team with over 10 years of space industry experience that build this bridge with the startups because it's a unique ecosystem. Can also be slow, but it can also give interesting R&D money to the startups. So there could be very large R&D projects that you do with space and ESA that you can also use then on Earth, but that nobody would finance you so easily, especially that the EU money is not there anymore. Second, in terms of financing for space, I forgot to point out the second startup that is purely for space. It's Coactum. It was on the map as well. It's actually a Catalonian startup that moved to Switzerland for the ecosystem here and for the ESA-BIC in Switzerland. We are very honored to have them. They will do the space metro, they call it, between the different orbits, etc. Clear Space got financed by ESA, you heard that. Coactum, I call it friends and royals. They have as supporters, friends and family. They started with a couple of millions from this source, but eventually they also will probably need ESA money, because in Switzerland or in Europe overall, the private space sector is not as much developed as in North America, for example. You all know the Elon Musk and the others that really push a lot of money into this sector. We have a bit of that in Europe, but not to that extent yet. So it's either that you have ESA money or are lucky that you get some other money, or what we have a lot in Switzerland, for example, is that space is one vertical of several. So it's one market and not only the main market. And then the whole business model and the business is easier. And last but not least, don't get me wrong, in Europe there's a lot of dynamic into the system as well. Also thanks to the new ESA director, an Austrian gentleman, Mr. Aschbacher, that started early last year. And he's very much pushing into speed, commercialization, private sector space, etc. So I hope that in Europe we don't fall completely behind in space. And thanks to Mr. Aschbacher and ESA and pushing, we'll keep up with NASA, North America, etc. So that brings me to the end. I hope I could give you some insights into what we're doing at ESA-BIC in Switzerland and the Swiss space ecosystem. And I'm open to any questions you might have.
Thank you very much, Nanya. Interesting presentation. Before we jump into the questions, let me just remind you for the public voting. So that's the last time. You have even now here a QR code that you can scan or go to menti.com, add the code, and then you can, for the next 1 minute, vote until we finish with our keynote speaker in. So let's get back to ESA-BIC. Questions from the audience? So we have seen, or you have seen 5 startups, and when will they be able to travel to Mars? Tell us.
Now, I had to consult my space expert for that question as well, but I have an answer prepared. Let's start with the moon. You all know NASA, ESA are planning to get back to the moon. In terms of individual persons, astronauts, that it could be as soon as 2024. In terms of some habitat on moon, they are kind of aiming for 2030. My space expert thinks they will not achieve it. It's always late, these things. So it's rather 2035, 40. So that's in terms of a habitat on the moon. Going to Mars, the person said maybe 2050, some individual astronaut going there. One key challenge is the one that I discussed with Sorab, how to get back with the fuel, right? That is a major challenge. And in terms of a space, a habitat on Mars, the person said maybe 2080. So I'm not sure during your lifetimes. Now you're a bit younger than us, or than me for sure. Maybe one of you will get some installation on Mars, but it is a far fetch.
So the two of us will be retired, but as you mentioned, the startups still have the chance to see their technology in action up there. So that's fantastic news. And as we know, Mars Habitat Challenge is a long-term vision. So that will help us there. So thank you very much, Nanya, for your presentation and the insights. Thanks for coming to Hagerbach. We have a small present for you.
Yeah, happy to see also the really great test facilities. We also discussed before maybe a potential collaboration, and maybe the Hagerbach Test facilities will also become a partner of ESA-BIC. Would be nice.
Congratulations.
Thank you, Nanya. We are looking forward to it. I have some flowers. I keep them in because they are already quite in the water, right?
I will travel with the base
without. We will prepare this accordingly, but just that you have this. And we have a small present also.
Ah, I've seen that, yeah.
This is out, a mature cheese here from the Hagerbach Gallery.
Thank you very much.
You're welcome.
It was a pleasure to be here.
Thank you for your time.
So, Mr. Kompatscher, please stay on site, and I'm also happy to call back Mr. Admiral. So we are coming to the closing of today, but first I would like to ask, what can the startup win here as a prize?
You already mentioned we offered the award Proof of Concept here in the Hagerbach Test Gallery. This has a value of 10,000 Swiss francs. And I think it's very nice because you can really do and implement the technology that you developed in the environment we offer here. And I'm looking forward to the winner that we can discuss and further fine-tune how we are going to implement it.
So that's a fantastic prize. So let's see who will be the winner of today. So the technique part is ready. And the winner of the Mars Habitat Challenge 2022 is... Let's see. Congratulations to So High Tech. Saurabh, please join us on stage.
Do you give it?
This is for you.
Congratulations. Thanks a lot. Pleasure. So I'm really looking forward to the hydrogen production we do here. Fantastic.
Photo moment.
Yes,
Well done.
moment.
Congrats. Picture time.
Great.
Congratulations.
Thank you.
So with that, we are almost at the end. I'm giving back to our host, and thanks for having the startups and us here. It was a fantastic event, and again, be underground, I think, with high temperatures outside, so it's very comfortable to stay here at Hagerbach. Thank you very much for having us.
Thank you, Stefan, to you. I would also like to thank to the sponsors, to the partners that helped us to make this possible, to all participants, and I think we do the final closing with the final picture here of all those that participated. We also have for the startups a small present takeaway that you can take with you. Thank you very much. Let's close with this here.
Thank you
from
much
stage.
also for joining
Thank
online.
you for all the partners outside and online. Yes.
Perfect. Thank you. So please, all the startups come on stage, and also Nanya, again, that we can do one large group picture all together. Startups in the middle. All right. Thank you.